Good day, everyone. Today we are going to learn about an important underground construction technique called box jacking. It is one of the modern trenchless construction methods used in civil engineering. In densely populated cities, it is often difficult to excavate roads because traffic movement, railway operations, and utility services like water supply and electricity should not be disturbed. In such situations, engineers use trenchless technologies, and one of the most commonly adopted methods is box jacking. Let us understand how this technique works. First, let us see why jacking methods are required. Suppose a new pedestrian subway has to be constructed beneath a busy highway or a railway line. Digging an open trench would completely stop traffic, causing inconvenience and economic loss. Instead, engineers push a precast structure below the existing road without disturbing the surface. This process is called jacking. There are three primary types of jacking used in construction: box jacking, pipe jacking, and arch jacking. Among these, box jacking is mainly used for constructing underpasses, pedestrian subways, drainage passages, and utility corridors. Now let us understand the principle of box jacking. Box jacking is the process of pushing a precast reinforced concrete box through the soil using powerful hydraulic jacks. The box is manufactured in advance and placed inside a launching pit. Hydraulic jacks apply a controlled horizontal force to slowly push the box into the ground. As the box moves forward, workers excavate soil from inside the box. This excavation reduces soil resistance and allows the box to advance. Since excavation takes place inside the box, the road or railway above remains undisturbed. This makes box jacking a non-intrusive or trenchless construction technique. This image illustrates the scale of the precast boxes used in the jacking process, highlighting the substantial nature of these underground structures. Let us now understand the working sequence. The process generally consists of the following steps. 1. Construction of a launching pit. 2. Casting or placing the precast RCC box. 3. Installation of hydraulic jacks behind the box. 4. Excavation of soil from inside the box. 5. Simultaneous pushing of the box forward. 6. Continuous monitoring of alignment and settlement. The excavation and jacking are carried out in small increments, usually a few hundred millimeters at a time, to maintain accurate alignment. One important engineering requirement is to prevent soil from being dragged along with the box. Engineers often use lubrication materials such as bentonite slurry around the outer surface of the box to reduce friction. Although box jacking offers many advantages, engineers face several challenges during construction. The first challenge is ground settlement. If excessive soil is removed, the ground above may settle, affecting roads, railway tracks, or nearby buildings. The second challenge is groundwater seepage. Water entering the excavation makes the soil unstable and increases construction difficulty. The third challenge is soil caving or collapse, especially in loose sandy soils. Therefore, proper soil investigation before construction is extremely important. Engineers generally carry out geotechnical investigations to determine soil type, groundwater level, bearing capacity, and soil strength before selecting the box jacking method. Now let us see one interesting solution for groundwater problems. When groundwater seepage is severe, engineers sometimes use artificial ground freezing. In this method, steel pipes are installed around the proposed excavation. A chilled brine solution at approximately -30°C is circulated continuously through these pipes. As heat is removed from the surrounding soil, the water present in the soil freezes. The frozen soil becomes a solid ice-like mass with higher strength and very low permeability. This frozen ground prevents water seepage and supports the surrounding soil during jacking. Generally, the freezing pipes are placed about 1.2 meters apart, although the spacing depends on soil type and permeability. Let us conclude with a practical example. Suppose a city wants to construct a pedestrian subway below a busy railway track. Stopping railway traffic for excavation is practically impossible. Instead, a precast reinforced concrete box is placed beside the railway line. Using hydraulic jacks, the box is slowly pushed beneath the railway while excavation continues inside it. The trains continue running safely above throughout the construction. This demonstrates why box jacking is considered one of the safest and most economical trenchless construction methods. To summarize today's lecture, box jacking is a trenchless construction technique. It uses hydraulic jacks to push a precast RCC box through the soil. It minimizes traffic disruption and environmental impact. Major challenges include settlement, groundwater seepage, and soil collapse. Artificial ground freezing can be used to overcome groundwater problems. Box jacking is widely used for subways, underpasses, drainage structures, and utility tunnels in urban areas. Thank you. For further learning, please refer to these resources covering construction technology and techniques.